All right. Well, good morning, everyone. Hopefully you can see the title slide here.
Yes.
Yes. Okay, perfect. Thanks. So I'm going to talk about concrete overlays for local agencies, and some of the pictures you'll see aren't maybe what you consider a typical local agency project, but we see a lot of potential overlap in some of the state highway projects are kind of similar to some of the county roads we might see, and then I'll also show some urban examples too, that while they weren't necessarily built by cities, some of them were built by CDOT. There's a lot of overlap there in some of the approach that local agencies could take. So just want to kick it off with that, just to preface it that way, and help you kind of make that connection to what we're trying to show. So wanted to start out just by showing this example from Terre Haute, Indiana, over 100 years ago. So overlays definitely are not a new thing. There's something that's been done for a long time. Although you'll notice that the technology has definitely changed. We use a lot more automated equipment. We don't water cure by flooding the concrete surface anymore. So a lot of changes there, but the overall idea is the same. I want to give just a quick history of Colorado's roadway concrete overlays, and started back in 1990 up near Fort Collins with the first section, and that was donated by industry just to get an example on the road, see how it would perform. It was built fairly thin with 3.5 and 5 inch sections, so definitely on the thinner end of even what we would typically build right now on a similar type of roadway. So that was out there. It was designed to last about 5 years, and it lasted quite a bit longer than that. I believe it was closer to 15 by the time it was finally taken out. And then as we started looking a little more closely and doing some research into concrete overlays, this one in 1996 was built up on State Highway 19 east of Longmont, and had a lot of research tied to it to lead to the development of CDOT's thin white topping design software. So used actual performance to develop those design equations and figure out the traffic, how the traffic loading impacts how the pavement performs, and all those things. So that continues to be used and evolves to address increases in traffic and what we need to keep the pavement performing. So just want to give a quick kind of an overview on the benefits of bonded concrete overlays on asphalt pavements, and just how that whole process works for people who may not be familiar with it. So we can cover an existing asphalt road with this concrete overlay, typically 2 to 6 inches thick, and we rely on the existing asphalt pavement to carry the load like a base would. So because it's already in place, it can help us as far as constructability wise, not have to dig into the subgrade and risk weather delays, things like that. So we're able to make it a fairly efficient process. It can eliminate some of the surface defects that you might see in the existing asphalt, especially in some of the heavy truck traffic areas where we could see a lot of rutting. And it overall improves the smoothness of the road by doing this concrete overlay. So I'll start just by going through the construction process. It's pretty straightforward. Milling starts with milling the existing surface typically. Part of this is to allow the contractor to control their quantities and have a better feel for how many cubic yards of concrete they would anticipate placing. Then sweeping the roadway, sealing any especially wide cracks that might be in the pavement. And then using just the standard procedure for placing a concrete pavement with a slip form paver. This is an example on State Highway 121 Wadsworth Boulevard. This is kind of the north side of Wadsworth, closer to US 36, project that was built in 2011. And so this is, a fairly urban application as an example here. And then I'll also show you on 56th Avenue in Commerce City, another urban example built back in 2011. And I believe that was a 5-inch overlay. So there are several examples out there that you can, drive around town and check those out and, see that the construction processes are just very similar to a typical concrete pavement project, a new construction. So one thing that we definitely get asked about is how do you deal with existing curb and gutter? And so one way to approach that is to overlay the existing curb, and that's been a successful approach in a number of places. So you can see here in this photo, as they're on the left, as they're overlaying this existing vertical curb with a slightly different shape curb in order to reduce some of the potential for cracking there. So there's definitely considerations on how you build the curb when you do that type of an overlay. But it definitely works well in those situations where the grades allow for it. And it's that curb overlay has been done along Parker Road in a number of areas. So, so we've seen it used successfully in the Denver metro area in a number of places. And one thing I want to point out too, on the thickness, I mentioned earlier some of the thinner pavement when we first started out. We kind of settled on, the 5 to 6 inch thickness works really well in most cases, and we can go thinner also when we add structural fibers in there too. So that's also an option when there are issues with grades and trying to meet some of the existing infrastructure that's out there and tie into that. So with that thinner pavement section, we also put our joints closer together. So we look at a 6 foot by 6 foot joint spacing typically. Here you can see an example. This one happens to be up in Wyoming, and this was 6 by 6 joint spacing on the roadway, and then 4 foot by 6 foot on the shoulder, just to divide that 8 foot shoulder in half. So that's how we work with some of those, some of those odd widths and make all that work. The reason that the panels need to be smaller is to reduce the edge stresses, and you can see that in the example on the top left. Kind of what that looks like when we're able to reduce the edge stress. And one thing I'll point out too, CDOT does have guidance in their M standards for concrete overlay jointing. So there is guidance out there when you think about, spec and plan development for a project. There are a number of tools that are out there that are available to use, and we can definitely help put you in touch with those if anyone is interested in that and needs those resources. And I'll share some more information at the end too about where you can find additional technical information. So just want to share a couple examples to show you what's out there in the Rocky Mountain area. So 8th Street up in Sheridan, Wyoming. Sheridan has a consultant and a contractor who did a number of projects over the years. So we have several examples up north of us, up in Wyoming, and then also over in Gillette. This happens to be an overlay on a cemetery road, and this one was about a 3-inch overlay, so a little bit thinner than some of the examples we're showing, but it gets a lot less traffic too. So I'll jump into another section of Wadsworth Boulevard. This one turns 20 years old this year. So another fairly urban application, although it doesn't have curb and gutter. But this was a 6-inch overlay. It's basically just straight north of C470. And I'm guessing a lot of you have driven this before, but about 45,000 AADT, a 3% truck. So gets a good amount amount of traffic through there, and we're excited that even with a design life, I believe this one was a 10-year design life. After 20 years, it's performing well. And 2 years ago showed 12 years of remaining drivability life, which we would anticipate would probably continue to extend even longer, and shows it in a really high performing condition. So so we're seeing some good performance out of all these concrete overlays, and I think they're a great solution in a lot of different applications. So one thing I wanted to share was design resources, and it's always good for us when we can share free pavement design programs and share where those are available. With as expensive as some of the design programs are out there that I know some of you are using regularly, it's nice to have the free ones. And that this BCOA ME that was developed by the University of Pittsburgh, Julie Vandenbush, spent many years of researching and better understanding concrete overlays, and so this is a lot of her life's work is in this BCOA ME program. And then pavementdesigner.org is another tool that you probably heard ACPA talk about in the past, and there are a number of tools in there, including for designing concrete overlays. It also links back to BCOA ME where it's appropriate to use that methodology too. So check those out, and Sarah and I are both happy to help if anyone has questions on those, needs some like walking through examples. We're happy to do that too. So please reach out to us if that's something that would be beneficial to you. And then as far as construction resources, and then also discussion on performance, MGPEC item 32, which you probably heard from Sarah this morning, is in the process of being adopted. It includes a section on concrete overlays. It's labeled white topping, which is kind of an interchangeable term that's been used in the past to refer to concrete overlays, but that's all covered in there. And then there are a number of resources too through the Concrete Pavement Tech Center, cptechcenter.org. There's performance history. It comes from Iowa in this case, but they have a long history of building concrete overlays, and a lot of them on county roads and in cities. So that's a great resource if you want to dig in a little bit deeper on what other agencies have seen. There's also information on developing construction documents. We really see the ability to use existing specs. And you'll notice in item 32 that there's really not a lot of difference between the concrete overlay, the white topping spec, and a standard construction spec. It's just a few extra considerations for those minor things that you do a little bit differently with a concrete overlay. And as far as the construction documents, we can do some pretty similar things to like an asphalt overlay as far as showing typical sections and kind of what you need as far as a section. It doesn't require a huge effort on the joining plan part of it, partly because typically the contractors will propose a joining plan that's based on their phasing of a project. So some of those things, if you have questions on those, once again, if you're looking at developing a project, please reach out, and we're happy to walk you through what's been successful and share some examples that way too. So you'll notice on the green covered document here is concrete overlays of asphalt parking lots, and I think we've talked about this at past MGPEC meetings, but just wanted to highlight a parking lot application since a lot of those are involved in in some of the work that you all do, and I know several of you have been involved in some of these projects that we'll show a few pictures of. So we'll shift into the parking lot side of things. Wanted to show a little bit of history back in the late 80s, early 90s. A couple examples here. And this one on the left, the church in Wheat Ridge, it was actually built by the parishioners of the church, so kind of a unique situation there. And then the one on the right, down in Monte Vista, Colorado, Leonard Velasquez has been doing concrete overlays for a number of years around the state, and has built some of the others we'll see too. A couple more recent examples, Pinehurst Country Club in Denver, and then also Thorn Creek Golf Course in Thornton. And I believe we had a presentation about that one within the last couple of years. So those are out there to check out. And we wanted to cover the Pikes Peak overlay at Dunn as an example of a recent project that was a lot bigger scale of a parking lot than what we normally see, and a place where we had to make some adjustments to, along the way, just to kind of address some of the challenges that were found in the field, and those come up, and as long as the owner and the contractor and the designer can all work together, we can definitely solve a lot of those issues that can come up. And I forgot to mention when I started, unfortunately, Dick Brasher with Concrete Works, whose company built this project, he is not able to join us today. Had a lot of things going on. He's outgoing chair of the CCA this year, and they've got a lot of activities this week. So so he's a little tied up, but I'm sure if anyone would be interested in chatting with him later about their experience on this project, he'd be happy to share his insights too. So I apologize that he was not able to be here today. So most of you probably know exactly where the Pikes Peak parking lot is, but here's an aerial view just to get you acclimated. And this is the before photos of this parking lot. You can see on the left the bus lanes, and then on the right more of the parking area. And there were a number of issues with drainage, and some wide cracks that had developed over the years. So there's definitely some repairs that were needed. And so the approach with it was to reconstruct the bus lanes with full depth concrete and then do a 5-inch concrete overlay on the remainder of the area, the parking area. And it was a pretty ambitious project from the beginning, and unfortunately was one of those COVID impacted projects that had to be cut because of the reduction in employments and the reduction in revenues that the Denver International Airport experienced in 2020. So they built almost half the project in 2019. They were just getting ready to start back on site in April of 2020, and then on April 7th, received notification that the second half of the project was going to be canceled. So while it was super unfortunate to have that happen, I know there's the airport was disappointed, the contractor was disappointed, but it's just one of those things that we have to live with it, with all the fallout from last year. So we are happy to say that there were 146,000 square yards of concrete overlay built out there. So I'll show you kind of what that looks like and what that interim solution is as we get to the end. The process, as you'll see, is very similar with this parking lot application as it was for some of the roadways that we just looked at. So filling the large cracks. In this case, they used a cement sand slurry, which worked really well. And then moving on to the paving. And in this case, they did a couple of test strips just to kind of get a feel for how it would all work in this type of situation. When you're dealing with a large mass of area, it's a little different than going down a straight roadway. So there were a few bugs to work out there, and the contractor worked closely with the owner and designers to sort through those. So one of the challenges that was encountered was this undulating grade. And I think this is one of the pictures that shows it best, and you can see that real dip there in the grade. And that can be a bit of a challenge for a slit form paver because of the size of the equipment, and using tie bar inserters can make it a little challenging too. So there were some issues to work out there, and that was mainly because of the whole drainage of this parking lot being designed with area inlets as opposed to sheet flowing, all in one direction. So a lot of those area inlets to work through and work around, but they were able to do that. One adjustment that was made is pulling out some of the tie bars where they really weren't necessarily needed, because this whole area was all locked together. Because of it all being one big mass, it really wasn't going to move anywhere the way we sometimes see with lanes separating a little bit on roadway projects. So pulling out the tie bars didn't have a negative effect, and it improved constructability and helped the project move forward. So a couple shots behind the paver, pretty typical finishing for what you would see. Nothing different from a standard placement. I think the one thing to point out, though, as far as finishing and getting the curing compound on quickly is important, especially when you're dealing with a really thin slab like we have here. So that's important to keep the moisture in and reduce the potential for cracking. And then the same 6x6 joining pattern that we saw on the roadway, it was implemented here. And so it's really important to have a lot of saws and potentially backup saws on hand in case equipment goes down. So in the fall of 2019, we had an open house on the project just to share a little bit about the project. I got in a little bit of trouble with Dick Brasher with Concrete Works when I talked about how easy the project was. But in all honesty, Concrete Works did just make the paving look easy with the way they built the project. So it really it was a pretty straightforward approach with doing the pilot lanes and then the fill-in lanes, and they really laid it out well to be able to build it pretty quickly. So here's a shot of phase one as it was nearing completion. A couple extra features in this project with the bus stops there, heated bus stops. For anybody who's had a chance to go out there, I'm sure those will come in handy. And then just all the lighting and those types of things that needed to be completed in order to be able to open this section. So this semi-permanent transition we thought it was just a temporary transition over the winter, but as it turns out, it's fairly permanent right now until or if extra funding becomes available to finish overlaying the rest of the parking lot. So this is what it looks like now. And kind of a wider shot there to show you the complete version. You can see the bus lane on the right and then the parking on the left. So slightly different joint spacing between those two. And then a little shot of the bus lane there, the before and after. So definite improvement with that bus lane reconstruction too. So I just wanted to wrap it up by showing the location of Colorado's thin concrete overlays. As you can see, a lot of them have been built by CDOT. But as a reminder, those, a lot of those are urban applications. And so, even though it's a CDOT construction activity, I think it carries over well into local agency type applications too. So where can overlays be built? Pretty much anywhere you need a durable surface and are looking to make your infrastructure investment go further. And as I mentioned, we can look at thicker and thinner applications and adding fibers and things like that where grades are restricted. So there are definitely a lot of options to be able to achieve whatever your requirements are. And wanted to share a couple lessons learned along the way too. For any of you who've driven on Parker Road and have noticed some of the lane separation that's happened between the concrete panels, one thing we've learned is we definitely need to tie those longitudinal joints. So that's big. Milling is beneficial, and I mentioned earlier for a couple of reasons. One is to be able to control quantities for the contractor. It can also help us to correct any grade issues that are out there. Material selection is important, and Sarah talked about this earlier too. But you know, the performance engineered mixtures really help us as we're looking at durability. We need to make sure that we're choosing our materials based on quality and how they interact with each other, so that we can pick the best combinations of those materials that provide you know, both durability, smoothness, all those other benefits we're looking for. We've seen lower annual maintenance costs out of concrete overlays, and CDOT's done some research on this too that we can share if anyone's interested. We've also learned that performance typically exceeds design life. A lot of these overlays are designed for 10 or 20 years, and we're seeing, you know, celebrating 20 years on several of them, and even more on others. So we're expecting that to continue, that performance life to continue to increase. And concrete overlays do save time during construction, since we're placing on the existing material that's out there and not having to get into that subgrade and risk some of the weather delays. So thank you. Appreciate the opportunity to present today, and please reach out if anyone has questions or would like additional discussion or just to review a potential project. We're happy to come out and take a look at it. Obviously not today with all the snow we're seeing here, but as soon as that melts, give us a call.